Hello, and welcome to the Gaming with Science podcast, where we talk about the science behind some of your favorite games.
Today, we'll be talking about Terraforming Mars by Fricks Games. Hey everyone, Jason here with a quick heads up about today's episode. We noticed there's a few little audio hiccups and hangs throughout the episode. Nothing huge, but it seems that the server we were using to record the audio was lagging a little bit in the process. We're sorry about that, and we're going to work to try to make sure it doesn't happen again. So with that, thank you, and on with the show.
Hey, I'm Brian.
This is Jason.
This is Laura.
And welcome back to Gaming with Science. We have another special guest star today. This is Dr. Laura Fackrell from NASA's Jet Propulsion Laboratory. Laura, can you give us a quick introduction to yourself, please?
Sure. I am Dr. Laura Fackrell. I am a geologist by training. So a lot of what I do, I'm familiar with a lot of things about rock and geology and plate tectonics and all sorts of things. But what I apply that to is really niche area called geomicrobiology, which looks at the interactions of microbes and rocks and also plants is something else I've applied it to. So my current work, I focus a lot on how do you take the materials that are available on the moon or that would be available on the moon if humans were there and trying to turn that into something that can support agriculture.
That's super cool.
Yeah, and the reason why I asked Laura to be on this episode is because I knew her when she was a graduate student, when she was doing basically the same things, but for Martian soil, right?
Correct. Yes.
Or Martian regolith. I guess it's not soil. We can get into the difference of that a little bit later. So first off, though, fun science fact. Brian, what fun science have you learned recently?
Oh, well, I usually try to find something that I think is themed. So this was making the rounds a couple years ago, right around the release of The Martian. Maybe you saw this about, can you survive on a diet of nothing but potatoes? Did you see this making the rounds? I'm sure everybody did.
I didn't actually know.
Oh, you didn't? So the short answer is sort of. You actually can't get vitamin B12 from potatoes. You need to, well, at least not in the current form. Of course, in the movie The Martian, he had plenty of vitamins to take that presumably would have provided B12. The meme was that you could survive on a diet of potatoes and butter, the butter providing the vitamin B12. Can you survive for a long time on that diet? Yes. Would you be healthy on that diet? Almost certainly not. So those are different things, I suppose. I also saw a study recently where somebody tried to simulate, can you grow potatoes in simulated Martian regolith? And they said sort of. So maybe it's not completely out of the question.
Yeah, and I assume when you're marooned, if you're marooned an entire planetary orbit away from Earth, survival is number one. You can worry about quality of life after that.
Yeah, but you're not going to get scurvy. Potatoes actually have a good amount of vitamin C in them. They provide a lot of calories. They are a good plant for that purpose.
Okay, so everyone probably got from the show title, we're talking today about Terraforming Mars by Fricks Games. So, little background about the game itself. First, Fricks Games is a Swedish company. It's distributed by Stronghold Games here in the US. Fricks Games is actually a family business. You look on their website, they're all members of the Frixelius family, which is just an awesome surname. It's like, I'm jealous of their surname. And Jacob Frixelius is listed as the designer of the game with his brothers, Isaac and Daniel, being given artist credit. It's a fairly standard strategy game, 1 to 5 players, so it does have a single player mode. 1.5 to 2 hour runtime. It lists, when Brian and I played it, took about 2.5 hours for us to go through it. Ages 12 plus, which I definitely get. I mean, I think you can play it younger than that, but there's a lot of strategy and planning and stuff in this that probably make that age appropriate. And well, MSRP is about $70 US, although I saw that even the company itself had it on like a $10 or $15 off sale. So you can probably get it on sale somewhere. Big thing with this is that it is number 7 among all board games on Board Game Geek.
Wow.
Which means that nearly 100,000 people rate this as one of the best games of at least the last 20 years, possibly ever.
And Board Game Geek people are notoriously fussy.
Yes. So like this is a little bit intimidating. This will actually be very intimidating when it comes time to give our grades at the end, because if we start disagreeing with Board Game Geek on this, there may be some flack headed our way. What's the game consist of? So physical components, you have the board itself, which is a giant map of Mars. It has a whole bunch of hexes on it, each representing about 1% of the Martian surface. And it's where you track your terraforming progress, where you put down ocean tiles and forests and cities. You also track the Martian temperature and air pressure / oxygen. And there's a few other things like the victory point track and a few other minor bits, but it's got most of it right there. You've got your player boards where you track your resources. There's a deck of project cards, which are the things you're doing to try to terraform Mars, little bits that you put on the board to mark when something has been terraformed, and then tons and tons of tiny little acrylic cubes, which I'm inordinately fond of. I don't know what it is about a clear slightly colored acrylic cube I just love, but any game that has that just goes up a few points in my mind. This one's especially fun because it has two types. It has the little colored ones to mark the players, and then it has resource cubes, which are actually opaque and metallic in copper, silver, and gold. And the gold ones are even a larger size. And there's just something really satisfying about having a pile of these little solid gold metallic cubes on your player board. It's just really fun.
I'm curious if you could go to Etsy and get actual upgraded metallic, like truly metallic ones so that they clink when you put them down.
Oh, I'm sure you can. It's like every game out there has some sort of upgrade, and something like this, oh, I'm certain of it. And I would be highly tempted to do that if I owned the game instead of you.
You can get it for me as a present.
So how do you play the game? Well, the goal of the game is to terraform Mars. And you represent one of several companies that are trying to do this. And I must admit, when I first read that, I thought this was like, oh, great, we're now in a corporate dystopia. And then you read the background, and it's actually not. It's actually surprisingly optimistic. The game starts 200 years in the future. Earth is running out of resources, fine, but there's no talk about like a climate crisis, no talk about wars or anything. There's a benevolent world unified government that is funding this through a universal tax. The companies are subsidized to go out and make Mars terraformed.
Yeah, it's a corporate utopia, not a corporate dystopia.
Yes, I mean, I'm sure you could get into the details there and have some fun like role-playing or fiction there, but the way it's set up, yeah, it's actually more of a corporate utopia. And then Brian pointed this out as we were playing. The game is competitive because you're all trying to be the best terraformer and ultimately win. But at the end of the day, it's also cooperative because no matter what happens, Mars gets terraformed. There's pretty much no way for someone to like screw Mars over and really mess things up.
Other than the one thing that I did where you can actually explode some nuclear bombs to increase the temperature, which does create, a little fallout zone in one tile. So whatever.
1% of the Martian surface, it's fine. The way the game plays out, you take turns, you draw your cards, you have to pay resources in order to keep cards. You take turns playing your projects, you gather resources at the end of each turn. I don't know why you gather at the end instead of at the beginning. I assume it has something to do with the way they wanted the game to play out. But most of it has to do with playing your project cards, which are things that will like increase temperature or increase oxygen or start building up engines that you can do. Or you buy milestones or sponsor rewards that give people victory points, just all sorts of things. And this is where I think the deep gameplay comes in and why it's number 7 on Board Game Geek is because since you're drawing relatively few cards and you can only keep a small subset of them unless you're super rich, then you can never really guarantee what you're going to get. And there's a lot of different strategies you can pursue to try to get victory points. You can try to build a whole bunch of plants and forests to get stuff. You can try to build cities. You can get extra bonus points on one thing. You can just try to terraform the heck out of Mars and get the most victory points that way. There's a bunch of different ways to try to pursue victory. And it's not always obvious who is winning because of that. So I think that's where the deep gameplay comes in.
Would you consider this to be a Euro game?
I'll be honest, I don't have a good definition of a Euro game. There probably is one out there. I just sort of have it feels Euro-ish. But my feel of a Euro game is kind of there's 10 things you want to do and you can only do 3 of them. And I didn't quite feel like that.
No, it doesn't really feel like that, is it? There's always something fun that you can do. There's just different things to do.
Yeah. So I could be very wrong about that. Like I said, I don't have a good working definition of a Euro game. Anyway, that's the game itself. We'll talk about fun later, but 100,000 people can be wrong, but probably aren't. So, but let's get down to the science.
Well, wait, Laura, did you get a chance to play this game? Have you played this before, or did you get a chance to look over it?
I have not. When you guys introduced it to me, that was the first time I'd actually seen it. But it looks really intriguing. It looks like there's a lot of startup that it takes a while to kind of like figure out all the pieces. It looks like it's a very well thought out, very, very fun, lots of really cool things there.
I think a lot of games like this always look really intimidating, but honestly, like 15 minutes around the table, you've got it. And I hope we get to play it with you at some point.
Yeah, it sounds like more of a business side of the aspect of terraforming Mars.
Yeah. And in fact, so the version that Brian has, I think it's a first expansion or something. It has a bunch of corporate cards that we did not play with, which actually get more into the economics and the business side of it, as opposed to just the basic terraforming. But they recommended not starting with that. And I can see why they had a lot more complexity and time to it. So we just played the basic, all you're doing is funding projects to terraform the planet. We have this bad habit. We need to find a host that we can actually play a game with before we get them on here, because so far we're 0 for 3. Oh, well, we provide game knowledge. You provide science knowledge. We're good.
I definitely enjoy a lot of games though, so this is just another example. I'll definitely add it to my repertoire.
Well, now let's get down to the science. And this is what we really needed Laura for. Because, I mean, Brian and I were both plant scientists. Terraforming Mars involves plants, but none of them can live there right now. And we don't know that much about how to make that happen. Laura, I guess maybe for background, can you give us some of the basic stats of Mars? I mean, I think most people know Mars is our fourth planet. It looks red, but can you give us some background so people understand, like, why is it that we're fascinated with Mars? Why is it that people even think it's possible to terraform it? That sort of thing.
Sure. Well, Mars is pretty cool. A lot of people talk about like the planets. They talk about Venus is Earth's twin because of the same size. But Venus and Earth are actually very different in a lot of their characteristics. But Mars and Earth are kind of another sort of twin. They're different sizes, but at one point Mars was actually, we think, a lot more similar to Earth in its character, in that it had like liquid water on the surface. It may have been slightly warmer with a more generous atmosphere. So there's a lot of things that have changed about Mars over that time. But because Mars was smaller, it cooled off very quickly, and it wasn't able to sustain that atmosphere during the early solar system when there's a lot of bombardment and things are being stripped away. And so it lost its ability to keep that atmosphere. And now it's become very dry, very cold. It does have seasonality to it, but they're pretty cold. So it ranges from probably like negative Celsius a little bit. So it does overlap with the temperatures we see here, but it gets way colder than anywhere on Earth ever does during different times of the scope. And it's definitely extremely dry. The driest places on Earth, like the Atacama Desert or certain areas of Antarctica, are wet for Mars.
So is there any water in the atmosphere, or is it all gone?
There's not much in the atmosphere except for temporarily. The atmosphere is actually very thin. So Mars is about 1/3 the gravity and like extremely thin atmosphere, mostly of carbon dioxide with a little bit of nitrogen and argon. But there's not a lot of water in the atmosphere. Most of the water is frozen in ice, and it can sublimate directly to gas, but it doesn't stick around for very long.
It just vents off into space, or it gets destroyed?
A lot of it escapes to space, and then there's a lot of different things that happen with it. But yeah, it doesn't stick around. It never stays around in liquid form, so you don't get a lot of liquid water in the air. So like it'll escape into the atmosphere, and then the atmosphere is so thin, it just the escape rate and the rate at which water is input into it, that balance just leaves it to be pretty dry.
We didn't really talk about this. We talked about compounded. I think we intended to talk a little bit about the phases of matter and how you can go straight from solid to gas, and then didn't actually talk about it and how that's affected by pressure, right? So in this case, there's just not enough pressure or temperature to maintain liquid water.
Yeah, pressure that comes from the atmosphere. So atmospheric pressure, there's not enough there to keep water in its liquid state, but it's so cold that it does stay solid pretty well.
Yeah, I was reading somewhere that apparently the stats are if you were to actually take all the water ice that is frozen in the Martian polar caps and melt it, apparently it would cover the entire Martian surface to like 11 meters deep for a little bit. And then, like Laura said, it would be lost.
Yeah, there's a lot we don't know about how much water is actually on Mars. Their estimates come with a large range of error because there's a lot that we still don't know, but we are learning a lot every day.
So this idea of the atmosphere being so thin because the planet is so small, I mean, could you have a thicker atmosphere on Mars? Is it possible?
So that's one of the big questions in terraforming. I should clarify that I'm not an atmospheric scientist, that if I get something wrong, I apologize. But I was talking to a lot of people who are atmospheric scientists recently at a conference just a few days ago. And there's actually a lot of talk right now for those who are looking at terraforming. They look at nanotechnology. And so if you take because there's not only water ice, but there's also dry ice on Mars. And if you kind of evaporate the things that are frozen in the ice and use nanotechnology to kind of help you with that, I didn't look into the details of how that would work, but they're able to, they were looking at the current escape rate of molecules and like the current rate at which the sun strips away the atmosphere and the technology that would be helpful for like seeding the atmosphere. They think that there's a way that they could do that, not with current technology, but that's a path forward to looking at actually creating a new atmosphere on Mars, then it could sustain it in the current solar system dynamics.
And I guess there's also this, can you maintain it over a geologic timescale or just the timescale that humans care about?
One thing I found while doing research is that one issue with Mars maintaining its atmosphere under current conditions is that it doesn't have a magnetic field. That apparently died about 4 billion years ago. And so the solar wind just basically is constantly stripping stuff off of Mars, anything that's light. And so anything you put up there, if it's a light element, then it gets stripped away, which I'm guessing is why Mars has so little nitrogen in its atmosphere compared to Earth, but I don't actually know that.
Yeah, that's a really big question. I do a lot with nitrogen. That's a big part of what I look at is how nitrogen is available and how you can do that in the soil. But yeah, there's a lot of pondering on whether nitrogen is in the atmosphere or whether in the past Mars had a lot of nitrogen, and they assume that it probably did. And that if it just escaped, or like, where is it now? That's a big question that we don't have a good answer to yet.
So what we need to do is, based on the documentary, The Core, we need to go and restart the core, right?
Core is like the worst geology.
Yeah. However, that actually does relate a little bit to the game, because one of the projects you can build is equatorial magnetic field or something to essentially create an artificial magnetic field for Mars. That is still like very science fiction, but someone did point out that if you were to put a very powerful magnetic field at, let's see, it was one of the Lagrange points, which we talked about in a previous episode. So one of these stable points in between Mars and the sun.
Oh, a magnetic shield.
Yes. If you put a powerful enough shield there, it would actually deflect the wind enough to maintain Mars's atmosphere. We don't currently have the technology to build a powerful enough field, but apparently it's only like 10 times higher than we can currently build, which like is a lot, but that's not insurmountable. It's like that could actually be feasible sometime in the next century.
How do you power something like that?
Well, the person I was talking with a few days ago, who is an atmospheric person, was saying that the current escape rate, you might not even need a magnetosphere or an ionosphere to protect it. That magnetic shield at the current loss rate might not be necessary. But at the past loss rate, when the sun was a little more active in its younger states, when it was very active and it's very hard to predict, and that solar wind is a lot more chaotic, it would have stripped away anything. And then Mars didn't have enough volcanic activity to replenish its own atmosphere. That's part of the story too, is also the current dynamics of the sun, and what we understand about that would play into it a lot.
I guess we should get away from the atmosphere and let you focus on the stuff that you actually want.
Yes, the geology.
There are 3 aspects the game has as key terraforming metrics. One is the atmosphere, which we talked about already. They use specifically oxygen. And I've got to say, I'm impressed at the research done in this, because they didn't just pull numbers out of the air, no pun intended. They actually did research on where do people live at the extremes on Earth. Okay, if we can get Mars to that, we're probably okay. So a common one coming up was like La Paz, Bolivia, which is something like 5,000 meters above sea level. It's very thin atmosphere. It's about 14% atmospheric pressure oxygen, which is the goal in the game. Also, its annual temperature, average annual temperature, is about 8 degrees C, which is your goal in the game. Once you reach 8 degrees C average temperature on Mars, you have terraformed it temperature-wise. And then the last one is water. So air, temperature, and then water, which I don't know where this one came from. They said if you get specifically 9% covered, that's enough to have a stable hydrologic cycle. So stable like evaporation, clouds, rain, and it kind of being self-sustaining as opposed to constantly having to feed stuff into it. So those are your 3 goals.
Some of these metrics also create positive feedback loops, right?
Yeah.
You reach a certain temperature, you get to add water. You reach a certain atmospheric pressure, you get to add heat.
And the atmospheric pressure would also play into how stable that hydrologic cycle is. So I feel like there's a lot of things that would overlap. So that's a really complicated model.
Yeah, but now let's get down to the part, because one part of the game, a very important part, is basically planting trees on Mars. It's greening the planet. And this sounds like it's right in your wheelhouse. What do we need to do to terraform Mars like that? What do we need to actually get things growing, assuming we can get like atmosphere and heat and stuff more or less under control?
Well, on a large scale, so this is a really great balance, because there's like the small scale, can you just take a small amount of Mars materials and do like a garden inside of a closed habitat, versus are you trying to plant forests on Mars? That's a huge difference. And I think the technology needed for either would be different. But a couple of things. So one of the biggest things about Mars that makes it difficult to grow things is its salinity. So if you take like a evaporative environment, you have a lot of salts being left behind. So if you look at a lot of deserts on Earth, or even just really dry air, like Antarctica would be a polar desert. And there's like a lot of salts that get left behind as the water evaporates, and you just build those up over time. And Mars has had thousands of years to be dry. And so there's a lot of salt that's been left behind. And a lot of those salts are very soluble. So you could potentially rinse them out of the soil, but that takes a lot of water. And so how you do that in a way that's actually feasible, and how you take the materials that are there and transform them into something that could support an entire forest would be quite a challenge. There are benefits in the sense that all the minerals, the nutrients are there. So Mars has a lot of phosphorus, more than Earth actually. So there's a lot of phosphorus on Mars. There's not a lot of nitrogen, but potentially you could produce nitrogen through waste, or if you put that back into the atmosphere in some way. There are trace nitrates, but it's like parts per billion is the most we found so far. But there's probably enough potassium if you harvest it from the right places. So these are NPK, nitrogen, phosphorus, potassium, are some of the biggest nutrients that you need for plants. But everything else is there in sufficient amount. Calcium, magnesium, plenty of that. Sulfates are a very common thing on Mars. probably too much sulfate, in fact. But those are easy to dissolve out. And so finding ways to balance that would probably be a big factor. And doing that and having enough water to actually do that would be a challenge.
So what's the best way to address the nitrogen limitation issue then?
I think one way is through just, if you're taking people to Mars, you're taking nitrogen waste. And so the human waste, any gardens that are growing within a closed habitat, all that plant waste, there's quite a bit of nitrogen in that. And so if you can figure out how to recover that and use things like denitrification, the nitrogen cycle is a really complex and very biologically driven kind of cycle on Earth. And so you have the denitrification takes nitrates and returns it to N2O, probably the easiest way to say that, turns it to the atmosphere. And so that will give you atmospheric nitrogen. And you also have nitrogen fixation, which some plants can partner with certain bacteria to do. And that can kind of bring it out of the atmosphere into a form that's bioavailable. So there's this whole cycle of nitrogen that would go along with the hydrologic cycle to kind of understand how that might be a function.
Okay, and so here we have where the Martian is accurate, because he was reusing recycled human waste in order to grow his potatoes because they needed them as a source of nutrients.
Mm-hmm.
I remember I read years ago, it was one of the Martian rovers was testing the soil, and they kept talking about how if you add water to it, it would get very caustic. Is that because of all these salts?
Mm-hmm. That's part of it, but that's also because of there's other things. So there's a specific type of salt called perchlorates and chlorates that are in the soil of Mars, and a lot of other magnesium chlorides and things that are exothermic when they react with water. So there is a lot of stuff in the soil that has been dry for a long time. If we added water to it, you can have quite a lot of exothermic reactions. You can have a lot of peroxide reactions and a lot of different things that could potentially do things to the soil. You also have a lot of pH ranges. And so depending on where you are on Mars, the minerals that are there indicate that it was acidic or alkaline or somewhere in the middle. So circumneutral. There's a lot of pH ranges. So depending on what particular minerals that you put that water in, you might get a lot of pH reactions.
And what's bad about exothermic and peroxide reactions? Like I'm trying to remember my chemistry. Exothermic gives off heat, or
Correct.
Okay. And what's bad about those as far as life is concerned?
Well, the exothermic reactions that give off a lot of heat. Well, I guess if you were holding it in your hand and you drop water on it and you had a lot of heat released, it could burn you. But for like life, it's more of a challenge in that for any kind of microorganism, like a bacteria that's living there, they have to know how to manage that heat in a way that doesn't like kill them. There are things that can figure that out and use that to their advantage. They can actually use that heat to like help it out. There's a lot of life that's figured things out like that on Earth in these crazy environments, but it would be really difficult to get energy out of that system in the right way for it to be supportive of life.
Also sounds like one of these opportunities for a feedback loop. If you have liquid water and it's mixing with perchlorates and then releasing heat, then you're heating the soil.
Potentially, I'm not sure how much would be there to heat it up. And like if there's other things that are going to counteract that chemically that would absorb the heats, that's hard to know. I don't think we know enough to really predict that accurately.
Oh, also, I said the soil word, so maybe we should talk about the difference between soil and regolith.
This is one of my favorite discussions about Mars regolith and soil. I think it depends on how you're defining soil. So if from a geochemist perspective, so as a geologist, I would call regolith a soil. In the same way that I would call like in Antarctica, where you have like this very, very rocky material that is basically its soil, that could be the same argument for regolith versus soil. And so as a geochemist, I think of soil as something that over time has developed and weathered and kind of stores the history of that area. And so I don't think of it necessarily specifically for growing plants. So that's one feature our soil can do, but it's also that it just stores the chemical history and like the geologic history, the weathering history. So how the rocks have weathered over time can be stored in that package of material. And so I feel like in that sense, it is a soil. And that's what we can tell a lot about the history of that area and how things have weathered and the behavior of different things in that system from that package of soil. But from an agricultural perspective, it's very much not really a soil in the sense that it's not developed into these like really nice horizons and layers. There are organics on Mars, but not enough to be like this rich organic layer in the O horizon or like an A horizon. So there's all these different things that go into soil science that we think of from like a crop and soil science perspective for like agriculture that it's missing. And so in that sense, it's kind of good to differentiate that it's not really a soil, it's more like a regolith. And so it depends on what context you're using the word.
Okay, so like regolith is usually like it's the ground up rocks on the surface of a planet. And then most of the time when we talk about soil, it's like, okay, it's then been altered by life into be something else. But you're saying it can also have a wider definition.
Yeah, soil is part of regolith on Earth. So Earth has regolith too. And it includes like the soil down into like slightly weathered bedrock. And it's kind of like a hazy line where one starts and the other ends. But once you like reach past like the weathering front and there's no longer weathering, that would be like the bedrock. But above that, where you have active weathering going on, you have different types of stages, soil is included in that package.
Ooh, now I've got another thing I want to add to my mineral collection. I need some earth regolith. So how do we get started? I mean, what are the first things you would put onto an enclosed environment on Mars to start turning that regolith into soil?
That's that's a complicated question to think about. So it depends on what you're doing. So it also depends on your approach. There's lots of different ways you can grow plants. There's a hydroponic system, or aeroponics and aquaponics and all sorts of aquaponic variations. That basically means growing with water, or like aquaponics, it's spraying the plants a little bit to support them, but it's like in the air essentially. Aquaponics involves fish, and so you create your own like mini cycle or mini system where the fish kind of provide some nutrients to, and then you kind of like have that recycling system. So there's a lot of different approaches you could use that don't even involve regolith directly. You still have to extract any fertilizers or water or other necessary resources, or even kind of rooting mediums that are common in hydroponics. You'd still have to obtain that from regolith or from ice mixed with regolith. And so it doesn't take regolith out of the picture. But there's a lot of approaches you could do that don't even directly grow it in the regolith by itself. But there are also plants that benefit from having that kind of soil-like environment that could use regolith as a component into how you develop growing mediums or like a potting mix. And so you just got to think of it like if you're making anybody's a gardener, if you're making a potting mix on earth, you add those different ingredients together. Maybe you have some peat or some coconut coir with some perlite and some sand, and that makes a really great potting mix. And so what are equivalent ingredients that you would need on Mars to do something like that? And so I feel like that's a great place to start thinking about what are we growing. And so the organic material, the early systems will probably largely rely on hydroponics because there's a lot of processing we have to do to the soil before it can be used to actually grow plants. And so in order to have that support there while that processing is happening, and that processing has to happen with other things too, like biomining or even just getting water out of the soil. So you're doing these processes either way. And so you're doing this processing on the side, you have to start with something. And so you might start with more of a hydroponic system and have mostly lettuce and things that provide nutrients that are hard to keep stable over that long trip to Mars. So that's one of the reasons to grow a garden on Mars. It's not just for food, but for specifically for nutrients and minerals, for vitamins that are very unstable and so would degrade by the time we got there and that humans need to survive. So that's what you kind of start with. And then you expand from there and kind of diversify from that.
Gotcha. So again, we want to avoid the space scurvy.
Yes, correct.
Okay, that's very cool.
So here's a question, Laura. If you were in charge of this benevolent world government that wants to terraform Mars, what would be your top priorities? It's like if you had to look at the planet from where we are right now and say, okay, our end goal 500 years from now is to be able to have people walking around on the surface of Mars, breathing and not dying. What would you do? What would you start that process with?
That's a really tough question and that gets really nuanced in the sense of, do we even want to terraform Mars? Is one of the big questions. Is there a benefit into preserving Mars as it is? And perhaps in this particular, the way that the game has framed it, we've kind of reached a point where we have to because we need those resources. And so we don't have much option. That's a whole nother ethics question there and get into a lot of that. But there's a lot we can learn from Mars in its current state about Earth and about how it's evolved and about prebiotic chemistry. And so like, what is the chemistry you need to make life or even early life if Mars managed to get life in the end? If Mars had enough time with those good conditions for life to develop, what does that life look like? And what can that teach us about life on Earth and like how it's developed and what it takes for life to start? And so there's a lot of questions that are preserved right now on Mars that plate tectonics has recycled on Earth. We have very, very few physical places to test that. And all those physical places have been greatly altered by weathering and plate tectonics and things like that. So it's not really preserved very well. And so if you head over to Mars, you have that preserved. There is no plate tectonics recycling the crust. And so we can study that there. And so how do you preserve that science that we're trying to learn about now? And maybe 200 years in the future, they've already gathered all the samples they need to do that. And so they can kind of set that aside. But then also, how do you do it sustainably over time? And so I feel like we tend to alter things in a way that's for the current generation, but you want to do it for hundreds of generations. Like, how do you balance that? And so prioritizing those things that aren't just like the flashbang, let's do it right now and it works, but like, will it work for a long time?
Agreed. And that is one thing that I've seen come up in the conversations, because there are people who are talking about terraforming Mars right now or starting colonies on Mars or whatever. And that's one thing I've come up is the ethics of it. And should we be trying to terraform this other planet, which is really hostile to Earth life at the moment? when we
Mhm.
have another perfectly good planet that maybe we should just
Yeah.
fix up and make a bit nicer?
Honestly, if we have the technology to terraform Mars, then we have the technology to terraform Earth. But if we get to that level where we can terraform an entire planet, we can fix Earth. And so why aren't we doing? That's kind of one of the things I bring up.
Yeah, it was interesting reading the groups that are currently involved in this. So one has gone defunct. There was the Mars One colony mission I read about.
Oh
Mhm.
no. Wait, is that the is this the reality show?
Maybe their funding model was that they were going to be selling documentaries of the selection process. But the really interesting thing is that their goal stated was a one-way ticket to Mars of their final people, which I think were going to be 40 people they were going to send, and they were not going to have a way to come back. Not surprisingly, many people thought that this was a suicide mission, and they had trouble getting funding. I don't blame them for trying. I mean, as far as a dream goes, that's really cool. And they had nearly 3,000 people apply for one of these spots. But their group unfortunately went bankrupt in 2019. So that
Mm.
is no longer on the table.
Oh, they didn't even get taken out by COVID. So
No. And then the other one, the one that most people hear about is Elon Musk, who has as a goal of using SpaceX to start a Martian colony. I think their current plans are like a first mission in 2029 or thereabouts, and then some sort of base by 2050s. There's lots of discussion about how feasible that is, but
Yeah.
they apparently think it's feasible enough that actually there is a clause in the Starlink satellite system that if you use that satellite, you are agreeing that Mars is basically a politically distinct entity and not subject to Earth's meddling.
I'm sure
Wow.
that'll hold up in international courts.
Yeah.
Yes. It's one of the things that means nothing right now. It's just an ideological thing, but I thought that was cool. And it's like, oh, that's one of the things they sneak into the end user license agreement. You have to agree that Mars is
Wow.
separate.
That's crazy. Well, and that's another huge area of like work that needs to be done that I am not an expert in is the government and the policies that go into how you ethically build a society on another planet or even another moon. Like how we're going to do that for the moon. There's a lot of things that we need to establish ethics wise and legal wise to make that fair. The ethics are a huge part of it.
Like, can you have children on Mars?
Yeah.
Because if you can't, that's not going to work. Particularly without a magnetosphere and with low gravity and with nutritional. It's just, there's a bunch of really fundamental questions that maybe need to be discussed before you start sending people to Mars.
hmm
And I got to say, like, science fiction is a rich mine here. People have been doing this for decades. And I know there have been specific stories I've read that have talked about
hmm
each one of these things. So, one that talked about the issues of burying children on the moon with low gravity and the genetic engineering that had to be that. I'm sorry, I don't remember which story it was. This was 20 years ago. I did grow up on classic science fiction. So, things like The Martian Chronicles from Ray Bradbury.
hmm
I think Bradbury kind of knew that Mars was a dead planet, but he still maintained that little older mystique of like there could be civilizations there and stuff. And if you haven't
hmm
read them, I strongly recommend it. They're great stories.
Yeah, there's quite a rich history of science fiction for terraforming Mars.
Yeah, and the game designers specifically cite Stanley Kim Robinson's Mars trilogy as inspiration for
Mm-hmm.
this game. 3 books, Red Mars, Green Mars, and Blue Mars, detailing the 200-year terraforming of Mars.
Yes.
Rich mind here. People have explored all sorts of like political organizations and the physics and the chemistry, the biology, the ethics. So yeah, that's the great thing about science fiction. It lets us ask what if about things that haven't happened yet.
Looking a little bit more modern, of course, we've got the Expanse series, which takes that idea, sort of, and like applies the science and the culture and the politics and takes all that very seriously.
Yeah, I have watched that one pretty recently, and there's a lot. I love how it dives into the human health aspects and the politics a little bit. And there's a lot we don't understand about how human health is going to respond to partial gravities. We have 2 endpoints. We have Earth gravity and we have microgravity. That's where we have most of our data from. And a lot of that data comes from very athletic astronauts. So it's kind of a very narrow data point to draw from. There is definitely effects. And so it's interesting to see how that might play out in kind of like that world, at least.
Although I think we can all agree the height of science fiction for this was the Stars on Mars reality TV show that came out last year on Fox, where they crammed 16 celebrities into the Australian desert in a simulated Martian colony and had them perform survivor-like tasks like erecting a comm tower, getting water, destroying alien fungus, and it was all hosted by William Shatner.
Oh, of course.
I'd never heard of it until I started doing research for this, but it's like, it sounds like it could either be awesome or a train wreck or possibly both at the same time. And the few reviews I read indicated that yes, it was actually a bit of both of those, depending on your taste.
I don't
Wow.
know if we'll have a chance to drop this back into earlier in the conversation, but when we were talking about this idea of preserving the current Martian environment
Hmm.
and looking for life, the game deals with both of those to some degree. There is a project to make sort of a Martian preserve where you sort of try to keep a part of Mars as it was before. Although to do that, you have to do it below certain temperature, pressure thresholds, or you lose the opportunity to do it.
Yeah.
And searching for life is a routine. It's just something you can do, right? Jason, you did that when you played, right?
Yeah, there were certain cards I could do where I could search for life, and if I got lucky on the draw, then I would get some sort of bonus points
Hmm.
at the end of the game, presumably finding some evidence of past life. I
Yeah.
don't think the game has any intention of there being present life on Mars that we are essentially,
Wiping out.
yes, basically. I think it's all like, oh, it's fossil stuff there.
Yeah. I
Yeah.
think
Yeah.
obviously, as microbiologists, losing the opportunity to study a second example of life, it would be beyond tragic.
Yes. So this is a really big part of the ethical and the scientific challenge of it. You have astrobiology, which is like the study of extraterrestrial life or the potential for it. And you have space biology, which is how Earth life responds to the space environment. And so as we do space biology, are we destroying our ability to do astrobiology? And as soon as you bring people to Mars, you bring bacteria to Mars. So
Yeah. I mean, we may have already, right? They try not to.
potentially in small amounts, but it's pretty harsh conditions. So it's unlikely that it's like spread far and wide or anything like that. But yeah, they have very, very strict bioburden requirements for any spacecraft that goes to Mars. So you have to get it extremely clean and even to send it. That's the planetary protection is what that's called.
Yeah, super clean. And then whatever manages to survive inside a NASA clean room probably is not adapted to survive that well in outer space and then on Mars itself. So, like, again, probability of infection being low. But humans are walking bags of microbes.
Exactly.
Like, literally, there's some arguments that part of the role of your intestine is basically to be a microbial incubator because of the
Hmm.
partnerships we have there. And so, yeah, we could never go to Mars without bringing a whole bunch of contamination with us. And I mean, most of it would just die on Mars. But to quote the great Ian Malcolm, life finds a way.
That
Yes.
documentary, Jurassic Park.
Yes.
So that's like a really big part of like studying humans to Mars. There's a lot of scientists who study astrobiology are like, how about we wait a little longer because they really want to dig into being able to understand if there was ever life on Mars. And is it that life distinct enough that we could differentiate? Because part of the problem is as soon as you put a person there and you contaminated it, can you ever declare that the life came from Mars? Or are they always going to go back to like, oh, but that could have been from a person?
Particularly if it ends up having DNA with the same code.
Yes. Although there's a lot of chemistry on Mars that maybe they just have a slightly different variation on DNA. I don't know. There's a lot to think about with how that could work and about life as we know it and life as we don't know it.
Unfortunately, I think we're starting to run a little short on time, so we should probably look into sort of wrapping things up.
Is there any last stuff you want to get out science wise?
There's a lot that we could talk about with astrobiology, but I won't dive into that. That's a whole other podcast, I feel like. So I think I can leave it at that.
When we find a good game, we'll have you back on to talk about that, okay?
Okay, before we wrap up, there's one cool science fact. So Mars has lots of cool science facts, but there's one I wanted to give, which is Mars has the record for the largest volcano in the solar system, Olympus Mons. And I wanted to put in context how big Olympus Mons is. So I looked up the stats. So this is a single volcano that is the size of Italy and 2.5 times taller than Mount Everest. That is one volcano we are talking about. And that's why it holds the record. And that's just awesome.
They've recently discovered some volcanoes in the deep ocean that approach that size.
Really?
Yes. The reason that I get that big on Mars is because it doesn't have plate tectonics. The plate isn't moving until it all builds in one spot. And so on Earth, that has to happen. It's hard to get that to happen on Earth. But there is one volcano they have found under the deep sea that approaches the size of Olympus Mons. But yeah, it's crazy. Mars has the biggest volcano and the biggest canyon and the biggest of everything. And yet it's like so much, it's like the quarter of the size of Earth.
And the slope of Olympus Mons is so gentle that I heard if you walked on it, you wouldn't realize.
All right, so let's start pulling this to a close. So the way we wrap this up, Laura, is that we're professors. We're used to grading things, so we get grades. Brian, I'm going to throw to you first about the gameplay. So this is your game. You're the one that actually owns the copy we played. What do you think of the gameplay on this? Where would you rate it?
Okay, so for gameplay, this is such a fun game to play. This is one of my wife's favorite games. Let me think. I usually rate gameplay based on how likely I might to throw it in the car or pull it off the shelf. And basically, there are plenty of games that we have that never come off the shelf. They just sit there, they look pretty, and that's pretty much the end of their involvement in my gaming hobby life. Terraforming Mars, in that regard, I'm going to give it an A minus. I think it's a little complex and it takes a little bit of time to refresh yourself. But I could easily see a gaming group or even my own group where it's like, this is just, oh, let's play Gaming Mars, and it's just part of your normal rotation.
I'd put it in that same area, kind of A minus. And it's just my experience that it does take a while. So our favorite games take about an hour and a bit to play. And this is definitely more the 2 hours plus game. And that's just personal taste. I think there's a lot of depth to it. And there's like 6 or 8 expansions of these, although my postdoc in the lab says that only 1 or 2 of them are actually worth playing. So take that for whatever it's worth. I have not touched any of the expansions. I don't know myself. Part of me feels bad saying that I'd give it like A minus A range. But number 7 on Board Game Geek. I mean, it's like, this is one of those places where I think maybe I'm wrong about this.
I think that the Board Game Geek community is just a different level of player. Do you know what I mean? Like, those are committed people.
Okay, time to grade the science. So I'm going to give the science an A. And I'm going to give it specifically because this game is not meant to be a science education game. And yet they did really good research into it. Like if this was meant to teach you about Mars and Mars science facts and stuff, I'd probably put it a little lower because it's not like as obvious, but they did their research in terms of like how much atmospheric oxygen do humans actually need? What sort of temperature will be worthwhile? There are little science facts scattered throughout the rule book about Mars and just random factoids. When you place tiles on the board, you get resources. You get trees more near the equator because that's where plants would do better. You get minerals near the mountains because that's where those are more likely to be. There's all these little touches that don't have to be there and yet show that even if this is not meant to be science education, it is strongly grounded in actual Martian science. And so I'm going to give that an A.
I would frame Terraforming Mars as a scientific game. I think that the science is in the center of it. And I give my science rating based on how much science you're going to learn, intentional or unintentional. And again, I think this is an A based on that. I think that you don't come away from Terraforming Mars not knowing more about what that process can look like and what it would entail. Laura, did you want to give a science grade? I know you didn't get a chance to play the game.
So it seems like it focuses mostly on the atmospheric side of the terraforming, although there is certainly the soil part of it. So it's hard for me to grade it because I'm not an atmospheric scientist.
Fair enough. That's where we're going to wrap it up. We want to give a big shout out and thanks to Laura for being on here. Laura, if people want to look you up, like how do they best find you?
I think the easiest way is probably on LinkedIn. My last name is not very common. So if you just look up Laura Fackrell, you'll probably find me, especially if you put anything with Mars or geology with that.
And then you said, so you're currently at the Jet Propulsion Laboratory. And then you told me that you're moving to some place in Texas to a commercial company?
Yes. So I'm finishing up a postdoc right now. So I'll finish that up. And then I'll relocate to Houston, and I'm going to be working in the space industry still down in Texas and Houston.
That's so cool.
Well, thank you so much, Laura. Thank you, everyone, for listening. And that's what we're going to call it. Have a good week and happy gaming.
Have fun playing dice with the universe. See ya.
This has been the Gaming with Science podcast, copyright 2024. Listeners are free to reuse this recording for any non-commercial purpose as long as credit is given to Gaming with Science. This podcast is produced with the support from the University of Georgia. All opinions are those of the hosts and do not imply endorsement by the sponsors. If you wish to purchase any of the games we talked about, we encourage you to do so through your friendly local game store. Thank you, and have fun playing dice with the universe.